This is Roberto and this is the HVAC is my channel. Today we're going to be talking about the pH diagram, and this is going to be part 2 of the previous video. In other words, we're getting ready to explain the refrigeration cycle in terms of the pH diagram, which is going to make it easier to understand that cycle. So let's get into it. All right, in the previous video we were talking about this region and the other region. So let's put that in here. So we're gonna put in here that was the subcooled region, and this was the superheated region, superheated region. Okay. So now what we're going to do is, since we're getting ready for this refrigeration cycle in terms of the pH diagram, which is very useful, we're going to put points, okay? So these this pH diagram let us understand in which state the refrigerant is. So as we remember from the previous video, the refrigerant is either going to be in 3 states, which are the vapor state, or a mixed state as a liquid and vapor, or as a liquid only. So let's put that just to remember, for the sake of remembering. So the refrigerant, which is the working fluid, is going to be mainly in these 3 states. It's going to be either a liquid, or it's going to be a vapor, or liquid vapor, vapor and liquid, which is a mixture. I just usually put it as a mix, or we're going to put it as a vapor. Those are the 3 main states. See, vapor, liquid, or liquid vapor. All right, so that's the refrigerant. For AC, actually, for air conditioning, we're going to have the 410A, and that's the working fluid that is going to be inside the line set. Where is this refrigerant going? So let's put that into pink. So this is called the line set. Goes inside, see, goes inside, and it comes from here to the coil. So whatever is insulated right here is going to be called the vapor line. All right, and what is not insulated is the liquid line. Liquid line. Yeah, maybe we made a mistyped this, and then liquid line. All right, so vapor and liquid line. So that's, and why am I putting pink? Because actually, whenever we're talking about 410A, that the tank itself, 410A, that's the refrigerant that we're using, actually has a tank. See, a tank that is pink, because this is color coded. So another refrigerant is going to have a different color. So it's especially for residential purposes, we have the 410A, which is pink. In the case of R22, it's going to be green. So now, since we have these 3 regions, we're going to put the points right here. All right. So let's put this right here. Okay. Say right here. Let's put that in here. There we go. 1, see, 1, 2 points. This is gonna come down. Okay, for the sake of explaining this, we're gonna put that in here, 0.3. Then it's gonna come, say, in here, 0.4, and then constant will be 0.5. All right, there we go. So we're gonna put this 0.1, 0.2, 0.3, 0.4, 0.5. So those points are located in those places because those are going to represent the refrigeration cycle in a system. So the refrigerant is going to be going in this cycle 1, 2, then 3, then 4, then 5, then 1, 2, 3, all in a series. It's going to be like that, okay? So now that's why it's important to understand what is in each location. So let's check on point 1. So on point 1, we're going to have the following. So on point 1, the refrigerant is going to be in completely liquid state. Liquid. So since it's in the subcooled region, they usually call it subcooled liquid. Subcooled. Completely liquid. All right. So now let's go for point number 2. In point number 2, we're going to have the liquid is inside this dome, this liquid vapor curve. So whenever you have a point on this side, you're going to have completely liquid. Whenever you have a point inside this curve, you're going to have a mix of vapor and liquid. And whenever you have outside this point, you're going to have superheated vapor. All right. So in this case, what you're going to have is mix vapor liquid, or liquid and vapor, whichever works. So for the sake of consistency, vapor and liquid mixture. All right, so that's going to be in point number 2. And then point number 3, in point number 3, you're going to have the following. In point number 3, since it's in this region, you're going to have superheated vapor. Superheated vapor. Okay? And now for point number 4, you're going to have again superheated vapor. Superheated vapor. Superheated vapor. Vapor. All right, and then we're going to go back to number 5, and in number 5, there we go, you're going to have this point that is called saturated liquid. Saturated liquids. Saturated liquid. We might have forget one point right here. So what we're going to put in here is an asterisk, and that's going to be 0.5. This one would be, say, 5A. Okay, 0.5A. So the 0.5A is going to be saturated vapor. Saturated vapor. And also, this is a quick mention. In the previous video, we were saying about the bubble point, and we were talking about also the boiling point. So actually, they are the same, because I was saying that on the saturated vapor line, we're going to have the bubble point, but it's actually on the liquid side. On the liquid side, we're going to have the boiling point, and right after that, we have the bubble point. And actually, on this side, we have the dew point. Okay, so that's just a quick mention. All right, so once we had these points right here, we have the states at which the refrigerant are. All right, so now there's another point in here that is very important to know, which is called the quality. Okay, so this is a little bit redundant, but I'm being a little bit redundant so that way we understand better what is the difference in this diagram. So we have the subcooled, the mixed, and the superheated. And now, when you have your state inside this curve, you're going to have a mix. But inside the mix, you also need to know what percentage of this is vapor. So in order to measure that, we're going to have the quality X. X is called quality. And this is actually the amount of vapor. Amount of vapor in a percentage. All right, so the amount of vapor in a percentage. For example, whenever you have in here, let's say that the quality is going to be like 0.2. So that means that it's the amount of vapor. So when you're talking about vapor, you are saying that 20% for X02 is going to be vapor, and since it's a mix, what's the rest? 80%. So the 80% is going to be liquid. So as you may notice, this is going to be 0.2, 3, 4, 5. In case it's 50% vapor, 50% liquid, until you get to this point. Quality of 0.9, it's going to be 90% of vapor and 10% of liquid until you get completely the saturated state. All right. So now what we're gonna do in here is also talk about because we're gonna be talking about the quality, we said that, and now the coefficient of performance, but that's gonna be possibly for the next video, okay? But now some other aspects of the pH diagrams are going to be also this. So we're gonna be using this line also. This line right here. Hopefully my pulse is very good. Okay, there we go. So that line is actually the constant entropy line. There we go. So that's entropy line. Let's put this with blue so we can see that. That's the entropy line. Okay, that's the entropy line. Yep. Now we're gonna put the same thing in here. It's gonna be okay. Okay, let's put in here, right here. We're gonna try to make it very straight as possible. Yeah, that's gonna be the constant pressure line. See, pressure line. Okay, it's gonna be the pressure line. Okay, pressure line. And now we also have this. Okay, we have, let's put in here pressure, which is A, entropy, which is V. Okay, and just to be consistent, entropy line, which is B. And then we're going to have the other one, which is the enthalpy. The enthalpy is going to be this. So enthalpy, these lines right here. See? See, that's called enthalpy line. Enthalpy, which is the energy content. And then we're going to have the last one right here, which is going to be the temperature. So the temperature actually is very interesting. So because it's very interesting, I'm going to put that line in pink, because that way we're going to be able to see better. All right. So for example, in here the temperature is going to come like this, like that, like that. See, it goes like that. See, and then that's going to be the temperature line. Temperature line. All right. So we have the pressure line, which is A. We have the entropy line, which is B. We have the enthalpy line, which is C, and we have the temperature line, which is D. Okay, we have the region which is subcooled, we have the other region which is superheated, and we have the middle region, which is the mixture of liquid and vapor. And also how much vapor, we know the quality means like 0.2. All right. So now in the next video we're going to be talking about the refrigeration cycle itself, but in this case we just have those lines. But now let's analyze a little bit more, just some more minutes about the definitions about enthalpy and entropy, because some of them are interesting concepts. In the beginning I would have no idea what enthalpy means or entropy, so that's why it's important to mention those ones. So enthalpy and entropy. What are enthalpy and entropy? So what we're going to put in here is the main concepts to remember very well what is enthalpy. So enthalpy, in single words, that's the energy content. That's all. Energy content. Okay, let's say in a fluid. So when you're talking about a fluid, you're talking about vapor or liquid state, right? So what would be the entropy? Entropy is a measurement of disorder. But entropy measurement of disorder, I would translate it into this pH diagram to be more practical. The amount of energy, let's say the amount of energy unable to do work, the amount of energy that cannot do work. All right, so those are the new terms like enthalpy and entropy. So enthalpy is going to be a very important concept, because the main reason of this diagram is that when we have these gauges, we're going to be able to obtain the pressure and temperature of the high side and low side. So if we have the pressure and temperature of the high side and low side connected to the outdoor unit, to the service valve ports, we're going to be able to find out the temperatures. If we have the pressure, we have the temperature. If we have the pressure, we have the temperature, we have the refrigerant. Of course, it's going to be 410A, or it's going to be 134A, or different refrigerant, and we're going to have the pressure, okay? So the main concepts are going to be that we're going to be able to have the pressure, we're going to be able to have the temperature. By who? By the gauges. Okay, and in the previous video we were saying that the pressure is going to be the absolute pressure, because for this pH diagram, which is from array, we need the absolute pressure, but this is going to give us the gauge pressure. Okay, we have the pressure, we have the temperature, and the main reason that we want that, which is easy to obtain, is in order to obtain the enthalpies, H. We need the enthalpies in order to find anything. For example, if you want to find out the heat rejected or the heat absorbed or the work of the compressor, we just need the enthalpies. So if you have the pressure in here, we're going to go down, you have the enthalpy right here. So if you have the enthalpies on every state, say that, for example, 3 to 2, enthalpy in 2 and enthalpy in 3, see, enthalpy in 3, you're going to say that it's like 119, and enthalpy in 2, you're going to have in here, say 20. You're going to be able to find how much heat is absorbed, which is going to be the net refrigerant effect. Okay, and then you convert that into tonnage, and you have your total tonnage. All right, so I hope you enjoyed this video, and don't forget to smash the like button and then share the video. All right, thank you very much. Thanks.